There are 3 types of radiation given off by radioactive waste. The first, alpha, is potentially the most dangerous, but only travels a few centimetres in air and can be stopped by a barrier as simple as a piece of paper. Beta radiation is less harmful, but can travel further, about 20 centimetres in air. It can pass through paper, but can be stopped by a few millimetres of aluminium or other light metals. Gamma radiation causes even less damage, but it can travel a long way and is extremely penetrating. Several centimetres of lead will stop it, or a metre or 2 of rock. As rock acts as a barrier to radioactivity, all the countries who have benefited from nuclear energy have concluded that the safest and most secure way to dispose of radioactive waste is to put the waste hundreds of metres beneath the surface in solid rock, by transporting the waste to tunnels and vaults in a geological disposal facility, or GDF. The thickness of rock above the GDF protects the waste from disturbance by humans and from the effects of any future ice age, erosion, or earthquakes. Dissolved radioactive materials could move in water, so as well as siting the GDF in rocks through which groundwater moves only very slowly, the natural barrier provided by the rock is complemented by a series of engineered barriers. Depending on their composition, wastes can be conditioned by turning them into solid blocks, or binding them together with cement or resin to reduce solubility. This forms the first barrier. The second barrier is formed by the containers into which the waste is placed, either with thick copper or steel walls, or concrete or steel boxes. The containers, filled with this conditioned waste, will be taken hundreds of metres underground, into the GDF. In the GDF, the containers are surrounded by buffer materials that protect them, reduce the passage of water to the containers, and minimise the passage of any radioactivity from the containers. These materials form the third barrier. The fourth barrier, of course, is the hundreds of metres of rock that separate the containers from the surface environment. So, between people at the surface and the waste, a set of carefully engineered barriers, a suitable container, for example made of copper, steel or concrete, a backfill of bentonite or cement, and lots of rock, will protect the environment and keep everybody safe until the radioactivity has decayed and the waste can no longer cause harm. The effectiveness of these barriers depends on finding a site where the host rocks and the rocks overlying the GDF have the right characteristics.